Hey everybody, welcome. This is the study guide video. So, watch, I guess. Alright, let's get through them. So our first one, 4 plus n equals 7, n equals 3, and then what do? We plug it in. So we had n, and now it's 3. So that's straight up substitution. We're taking a player out, putting a player in. So that's f. Here, it looks like I have a and then 2a. And then negative 5 and positive 10. I think that's a typo, but what should be happening is I'm multiplying both sides by 2, multiplication property. Here, it's the same thing, 3x equals y, and then it's y equals 3x. That's flipping it around, so that's symmetric property. I have 4w minus 1 equals 11, and then I have 4w equals 12. Well, it appears I'm adding 1 to both sides, which would be addition property. Here, we have a plus b equals c, c equals d squared, a plus b then equals d squared. We could argue this is transitive because I'm setting them equal to each other, and this appears most likely to be transitive property. That tying piece is they both equal c, so we can set the two equations of a plus b and d squared equal to each other. 6y, that's reflexive property. Here it looks like I have the negative 8, and now it's gone. And I had negative 56, and now it's 7, so I must be dividing both sides by negative 8. Here, I have 5k equals negative 25. Then I have 5k minus 1 equals negative 25 minus 1. Looks like I'm subtracting on both sides, so that's b. And then this appears to be a parentheses, and then no more parentheses. That's a good indication this is probably distributive property, which is e, not d. All right, there you go. Those should be hopefully easy points. It's just studying. All right, a lot of these questions, it's a good idea to draw a picture. It says A is the midpoint of CM. So I'm going to write CM. A is the midpoint. As soon as I hear A is the midpoint, I'm marking those congruent. And it says CA is 2x minus 3. And CM is 5x minus 11. Now this is why I want to draw a picture. You might be tempted to hear midpoint and be like, oh, set them equal to each other. But is CM going to be the same length as CA? And the answer is no, because CA is half of CM. But that means this piece right here is also 2x minus 3. So we could do 2x minus 3 plus 2x minus 3 equals 5x minus 11. So I'm in fact using actually the fact that I have two little pieces set equal to a big piece, which is segment addition postulate. But I also use midpoint to help me find those two smaller pieces. Combine like terms, we get 4x minus 6 equals 5x minus 11. If I subtract the 4x, I get x. If I add the 11, I should get 5. X equals 5. Then it says to find the length of AM, which is the same length as CA. So I'm going to take CA and plug in 5. That's going to be 10 minus 3. So if CA is going to be 7, then guess what? AM is also going to be 7. Next, fill in the following diagram. C is the midpoint of AE. So C is the midpoint of AE, so that means these two segments are congruent. And B is the midpoint of AC. That means these two segments are congruent. AE, the whole thing, getting kind of confusing with all these colors, right? So AE, that whole thing, is 28. CD, this little guy right here, is 3. And AB is 7. Find all the values below. So AC, well, AC is pretty easy. If AB is 7, BC is also 7. So AC is 14. And then DE, well, if this is 14 AC, we know CE is also 14. So if I take 3 away from 14, I get 11. And 14 plus 14 is 28. So that looks pretty good. To me, everything happens to match up. R, S, T are collinear. That means they're on the same line. And it says S is between R and T. So we know S is somewhere here. R and T is like this. We have RS is 2W plus 1. ST is W minus 1. And the whole thing is 18. This is definitely screaming segment addition postulate. So we get 2W plus 1 plus W minus 1 equals 18. Combine like terms, 2W and W is 3W. 1 minus 1 is 0, so we get 3w equals 18. W is going to equal 6. But then it said find RS, so we plug it back in. And we get 2 times 6 plus 1. That should be 13 for RS. Okay. Alright, so this picture we use multiple times, so I'm going to switch over and use a pencil if I have one. So if I can make some adjustments. But this first part's going to stay the same, so I'm going to mark it. But KJ, KJ and KM are opposite rays. We know this is 180 degrees. KN right here bisects KJL, so I know these angles are congruent. And now let's do everything else in pencil. So JKN right here is 8x minus 13, and NKL is 6x plus 11. Solve for x and JKN. Well, they're congruent, so you set them equal to each other. Subtract the 6x, we get 2x. Add the 13, we get 24. Divide by 2, and x equals 12. And then JKN is this guy, so we're going to get 8 times 12 minus 13. And I'm going to use the calculator so I don't make a mistake. And I get 83 for JKN. For my two answers. Then I have to go and erase these because we're going to use the same picture for the next problem. And it says JKL. So JKL is this whole angle here is 3x plus 30. And LKN is 2x. Find y and NKL. Well, if we add this whole angle plus this little angle, we should have 180 degrees. Those are supplementary angles. And I accidentally did number 15. So let's do 15 first because I skipped number 14. So we add those two angles, set it equal to 180. This is going to become 5x equals, subtract the 30, 150. X is going to equal 30. And then find NKL. So NKL really should just be half of this whole angle. So if I plug it into 3x plus 30, divide by 2, we should have our answer. So 3 times 30 plus 30. 3 times 30 is 90 plus 30 is 120. So 120 is that whole angle. I want to divide it by 2. And so the measure of NKL should be 60 degrees. Okay, so again, I plugged it in. Here we got 120 for this whole thing. I only want this piece, but since these are congruent, this has to be half of 120, which makes it 60. All right, let's erase, and let's actually go back and do 14, the one I was supposed to do, but I didn't do because I am a genius. And I'm just like, oh man, let's just get to the 15. Looks so fun. JKL. So JKL. Oh, you know what? I probably actually ended up doing this wrong. I think I read part of this one and part of that one. Oh man. All right, we'll fix it. JKL. So JKL, again, we have the whole thing here, is 9y plus 15, and JKN is 5y plus 2. Okay. If this is 5y plus 2, this is also 5y plus 2. So this is going to be angle addition postulate. We're going to add 5y plus 2 together, both of them, and set equal to the whole thing. Okay, that's going to be 10y plus 4 equals 9y plus 15. Subtract the 9y, I get y. Subtract the 4 over, I get 11. And then JKL, we just plug it in here, so that's 9 times 11 plus 15. That's going to be 99 plus 15, which gives me 114 degrees for the measure of JKL. Okay, let's go back to number 15 because I totally messed that up. Way to go, Mr. Smith. This is why I should never do problems where you use the same picture, because even I got it wrong. So we got to redo 15. My bad. It looked pretty good. It's a good practice problem, I guess. But no, we got to redo it. 15, redo. All right. 15 says JKN, so I messed that up. So JKN is this piece right here. So that's 3x plus 30. And then LKN is the 2x. Okay, we can fix this though, it's not a big deal. I can't set those equal to each other. Those are not vertical. They almost look vertical, but these would have to be opposite rays coming out, not this flat one. But if this is 3x plus 30, this is also 3x plus 30, and now I could say all three of those add to 180. That's what I wanted to do. So we get 3x plus 30 plus another 3x plus 30, because those are congruent, plus the 2x equals 180. I'll switch over to my pen. So 3x plus 3x plus 2x, that's going to give me a total of 8x. And 30 plus 30 is 60, equals that 180. Subtract it, the 60, and we should get 120. Okay. And then we're going to divide 120 by 8. Does that go in perfectly as much as I want it to? It does. X equals 15. And then it says NKL. So if we look up here, NKL is this piece. So it's the same as the 3x plus 30. So I just do 3 times 15 plus 30. That's going to be, I believe, 45 plus 30 is 75, I want to say. Yes, it is. So the measure of NKL is 75 degrees. All right. Whew, we got out of there. Barely alive. All right, find x and y in this image. Well, the y there's only one of, so let's solve for the x's. So what are these two x's? Well, this is a great example of a linear pair. So linear pairs are supplementary, so we're going to add them and set it equal to 180. If you haven't figured it out, pretty much this whole test is adding set equal to 180, or setting equal to 90, or setting equal to each other. All right, 25 and 9x should give me a 34x. 8 and 2. That's myself. It should give me 10. 180, subtract the 10, we get 34x equals 170. 170 divided by 34 is 5. X equals 5. And that's all I need to do is find x. But I also need to find y, so it'd be helpful if I actually found this here, because these are vertical. I can set them equal to each other. So 9 times 5 plus 2. Ooh, I'm allergic to math. 9 times 5 is 45. 45 plus 2 is 47. So we're going to set 7y plus 5 equal to 47. Subtract the 5 on both sides, and you get 7y equals 42. Divide by 7, y should equal, I think that would be 6, if I'm not mistaken. And it is. Alright, so linear pair, add 180, plug x value in, and vertical angles. Oh man, as if it wasn't over. It's not. Here we go. Supplementary means add to 180. So we get 4x plus 8x equals 180. And we're going to get 12x equals 180. And then 180 divided by 12 is equal to 15. So x equals 15. Angle 1 is 4 times 15, which I believe is 60. 8 times 15, well, that should be 120, twice as big. 3 and 4 are complementary, so you're going to add those up to 90. I mean, the math almost can't get easier than this. It's the vocab. Vocab. So that's 2x equals, I'm going to subtract the 24 right away. Gives me 66. X equals 33. What's angle 4? Well, that one's easy. 33. And then I kind of cheat because you can just do 90 minus 33. It's 57. But that's what I should get. 33 plus 24? 57. Okay, I gotta blow my nose, so I'll BRB. Okay, I'm back. The power of video editing. I was gone for like an hour. Blowing my nose. No, I wasn't. Alright. Speaking of, I think now would be a good time to say, let's see, on the last factoring problem on the written test, write down the secret code, banana pancakes, and I'll give you extra credit. Don't tell anyone. Alright, 2 lines intersect to form angles. If the 2 adjacent angles are formed 4x and 5x minus 27, then what's the measure? So two intersecting lines form angles, the two adjacent angles. So if I have 4x here, the adjacent one will be right next to it, 5x minus 27. Could have been on the other side. Either way, this makes a linear pair, which means they add up to 180, because that's what we do in this class. Okay, so we get 9x. I'm going to add the 27 over. That should give me, what, 207? And then divide by 9. So 207 divided by 9 is 23. And it says, what's the measure of the two angles? So 4x, the 4x angle is 23 times 4, which is 92. And then the 5x minus 27, remember that has to equal 180. So that should be 88. To make that true, we can check 5 times 23. I'm just doing this in my calculator. 5 times 23, and then minus 27 is, in fact, if you can kind of see with the glare, 88. So we're good. 1 and 2 form vertical angles, so vertical angles are congruent, so we just set them equal to each other. And subtract the 4x, that gives me 12x. Add the 9, that gives me 12 conveniently, x equals 1. Find the two angles. Angle 2 is really easy. 4 times 1 is 4 plus 3, which is 7. So that means this one's also going to be 7, because they have to be the same. L and P are a linear pair. I see what you did there. So you add them up, set them equal to 180. It's the exact same problem as this one up here. If you're wise, you will notice it's the same values. You just had to know these were a linear pair as well. So you end up with actually 92 and 88. That one's called the time saver. Okay. These form a linear pair. Add them together, set them equal to 180. All right, let's do it. 18x minus 1 plus 23x plus 17 equals 180. We get 18 plus 23, that's going to be 41, I think. 41x. And then plus 16 equals 180. 41x, and we're going to subtract the 16 across, so it's going to be 164. And then we're going to divide that by 41, which gives us x equals 4, which is important, but we want to find angle 2. So the measure of angle 2 is equal to 23 times 4 plus 17. And we should get 113. Yes. All right, last 3, and then it's proof time, and I think some factoring. So we still got, wow, this is a long, we had a long study guide. Okay. 1 and 2, what kind of angles are they? They are complementary, so we're going to set them up to add and equal 90 degrees. So we get 4 plus 3 is 7x, 13 plus 14 is 27. Subtract 27 from 90, which is 63, and then divide by that, x equals 9. And it says find the measure of angle 2. So the measure of angle 2, that's going to be 3 times 9 plus 14. And so, let me calculate that on my calculator just to be careful. So, times 3, which is what, 27 plus 14 is 41. 1 and 3 are vertical, so we can set them equal to each other. 54 equals 5x minus 6. Add the 6 over, we get 60 equals 5x. Divide by 5, and x should equal 12. 4 and 2, they're equal to each other, so that's 37. That one's easy. All right, proof time. Now, everyone loves these ones. So these are just algebraic proofs. It's just a flow, so you just flow down from one step to another. So the first one, given, you don't have to wrap your head around any of this. From here to here, it appears that we subtract 6x over, so I'm going to say subtraction property of equality. Number 3, I go from here to here. It looks like I'm adding 17, so I'm going to say addition property of equality. From here, it looks like a divide by 2, so I'm going to say division property of equality, and then from here to here they flip, which is symmetric property. Sweet. All right, nice. Now we got something really good to look at. WY, XZ, so those are congruent, and I'm trying to prove that this segment is congruent to this segment. Okay, I think we could do that. It kind of makes sense. Like if this blue curve was 10, and this blue curve was 10, and let's say this was a value of 2, well, if this was 2, this would have to be 8, but if this was 2, that would have to be 8 as well, and I just proved they're congruent. So it makes sense if I try a number and plug it in. Let's jump in. I'm assuming we're going to use segment addition postulate here because I see 2 segments adding up, right? I see one little segment plus another little segment adding up to make a bigger segment. I bet you we're going to use some transitive property as well, or substitution, some things. So that's kind of where my head is at on this one. So let's start with the given. Okay, then I go from congruent to equal. If you ever go from congruent to equal or equal to congruent, you're talking about the definition of congruence. Now I see what appears 2 segments equaling up to a bigger segment. This is definitely segment addition postulate, right? I kind of foresaw this. So I like to, when I look at the picture, I like to start thinking of vocab words. Now this also looks like segment addition postulate, but I just proved that these 2 add up to this. I just did a couple of different ones that add up to the whole thing. So I'm thinking this is a little different. What does this look very similar to up here? And I already stated yz equals xz, so that's kind of important. So actually these 2 equations, let's see, yeah, this equation and this equation are almost identical, okay? They're almost identical. The only difference is this one has a wy and this one has an xz. So how do I switch those out? Well, I said up here that they were congruent. So I can actually do a substitution property where I sub wy out for xz. So that's substitution property, not transitive. Now here I'm setting 2 equations equal to each other. Well, where do these equations come from? Well, where is this guy? Well, this guy's right here. And where's this guy? This guy is the one that we just established right there. So if we look at those 2 equations up here, what do these have in common? They're both equal to wz. So in all of our classes, I said, you know, someone's the same height as Mr. Smith, so we'll just call person 1 is the same height as Mr. Smith, person 2 is the same height as Mr. Smith, so person 1 must be the same height as person 2. That is our example of transitive property. Then from here, I go from 5 to 6. They both had xz, so it looks like I just subtracted that. So subtraction property. And then I go from equal to congruence. That's definition of congruence. A. All right. I see 2 little angles and a big angle. Angle addition postulate is now sticking out to me. It says Km is bisecting JKL, so I know these are congruent. I want to prove that MKL is half of JKL, which we know that has to be true because it got cut in half. So the first thing is it bisects. That's just given. Now I'm showing that these 2 angles were congruent. How do I know that's true? Well, it was the word bisect that told me that, so it's the definition of bisects that tells me they're congruent. Now, angle addition postulate, I knew this was going to come up, so I'm going to do JKM. So the measure of JKM plus the measure of MKL should equal the whole thing, which is the measure of JKL. Okay, now these 2 equations look the same. The only difference is, right, this piece is different. And why is that? Well, we did say up here JKM is equal to MKL, so I'm simply just substituting that value in. And then it says combine like terms. So I look up, do I have like terms? Well, MKL is here twice, so we could write 2 times the measure of MKL equals the measure of angle JKL. And then we get just 1 MKL over here in half, so I must be dividing by 2, so that's division property of equality. Almost forgot that. Flip it, rip it, grip it. Oh, algebra. Let's do it. All right, so we get 8x minus 1 equals 5x minus 35. That's given. The first thing I'm going to do is I'm going to distribute. So I get 8x minus 8 equals 5x minus 35. So that was distributive property. Then I'm going to subtract the 5x over to get 3x minus 8 equals negative 35. So that's subtraction property of equality. And then I'm going to add the 8 over. So that's 3x equals negative 35 plus 8, which is going to give you a negative 27. So that was addition property of equality. Oh, I didn't say prop. My bad. And then last but not least, divide by 3, x equals negative 9. That matches my proof statement. Never write the word prove here, ever. Last step is I did division property of congruence. Okay. Factoring time. All right, let's factor. Again, let's just do all of our little x factors. It's going to be so fun. Okay. I don't know if we actually factor all of these or not, but this one right here, 120, what multiplies to 120 adds to negative 22. If you don't know, just take 120 and start dividing it by numbers. I'm going to try 4. I don't know, I'm feeling lucky. Nope. I'm trying 5. 5 and 24? Nope. I'm trying 6. 6 and 20? Nope. I'm trying 8. 8 and 15? Nope. Oh, duh. 10. How stupid am I? 10 times 12 makes 22. That was dumb. They're both negative because we have to get a positive value when I multiply, but a negative value when I add. And so they're negative 10, negative 12. This one, before I x factor, I have to divide everything by 2. So I get the 2 on the outside. We get x squared plus 14x plus 45. So what's 45 and 14? It's got to be 9 and 5, right? 9 times 5. Looks good to me. X plus 9. X plus 5. Leave that 2 on the outside. All right, let's go to this one. We get negative 126 and 3. So the number, since the number I'm adding up to is pretty small, I gotta try like decently large number. I'm gonna try 14 and 9. That's close. 126 divided by 16. Nope, 126 divided by 18. 18 and 7. I think I'm getting further away. 126 divided by 12. No. 126 divided by 10. Obviously that wouldn't work. 126 divided by 8. Did I do that one already? No. 126. I could have sworn it was 14. 14 and 9. Nope. Okay, I got this, guys, because that's a difference of 5. So we gotta get closer. Numbers closer to each other. 126 and 16. I feel like I already did 16, didn't I? I did. 17 doesn't go into it. 18. 18. No, that's a difference of 11. Now I'm getting further away from the truth. Okay. Let's see, did I write it down correctly? Okay, I know this one. Let's come back. It will hit me. All right, this guy right here, we have a 3 in the front, so let's divide by 3. You get x squared minus, so 108 divided by 3 is 36. And so we want to multiply the 36, my x value. Like here we had negative 22 in the x value. Here I have none. So what do I do if I have no x value? Just put 0. What two numbers multiply to 36 but add to 0? Well, that'd be positive 6 and a negative 6, right? So that's one way to do it. Just say, hey, my value on the bottom is 0. Same thing with this one. Negative 121 and 0. So what two numbers multiply negative 121? Well, that would be 11 and negative 11, right? And you can check it on your calculator. And so we get x minus 11 and x plus 11. This one here, we have to factor an x out first. So we get x squared minus 6x minus 72, negative 72, negative 6. I'm guessing 72 and 9. That'd be 9 and 8. No, let's try 72 and 6. 6 and 12. Sounds good to me. One of them has to be negative. It's got to be the 12. So we're going to get x on the outside, and then we're going to get x plus 6 and x minus 12. And that one's good. And that one's good. And this one may be unfactorable. Let me check real quick. One more time. Okay, so I ran through all of them. We can list them out, and I just don't think we get there because we get 9 times 14, which is the two closest numbers I can get. They don't make 3, so I'm going to go with not factorable. We could solve it, but not by factoring. All right, good luck to you. Bye-bye.